Hello. Hello everybody, welcome to ACE Engineering Academy and ACE Online. So today we are going to start RRB JE revision series with PYQs for electrical engineering students. Right students, so starting from today, so continuously, so every day we are having one topic, one subject of electrical engineering. Today and tomorrow we are having power systems, later on we are having the different subjects. Every day, so it will be starting at 7 p.m. every day. So students who are on the line, so please take care and listen the classes clearly, and we are discussing the PYQs also here. Alright students, the first subject that we are going to start, here it is the power systems, myself Prasad DMV, right. So power systems is one of the most important subject of electrical engineering, where we are having lot of syllabus, right. So the syllabus of power systems, we can say generation of electrical energy, transmission and distribution of electrical energy, and fault analysis, along with switchgear and protection, and utilization of electrical energy, estimation and costing, all these comes under the power systems part. Right students, so we will discuss some topics here, at least some topics, so based on the time, and we will discuss some questions here. And where we have taken, where we are discussing all these things, from which textbooks, right, which standard textbooks we follow, means they are the standard textbooks we can follow, right. So one is Stevenson, and one is Duncan Glover, and one is John Wheely Publications, and one is D.P. Kothari and I.J. Nagra, right. So this is William Stevenson, and this will be Duncan Glover, and this will be John Wheely Publications, and this will be I.J. Nagra and D.P. Kothari. So they are some of the standard textbooks we can prefer for learning concepts of power systems. Right students, so along with these we are having lot of textbooks which are available in the market, right students. So we are unable to take all the textbooks, right. So at least one textbook we can take, right, and we can learn the concepts from the topic, from the textbook, right. So what you have to practice to get maximum marks means, so first of all we have to practice previous SSC JE and RRB JE questions, definitely we have to practice, and UPSC civil services as well as engineering services previous questions from power systems, not only for power systems, this will be common for all the subjects, and previous PSC questions, right. So it may be ISRO, or it may be DRDO, or it may be BARC, anything, right. And previous GATE 1 mark questions you can take, and previous state board questions like GENCO, TRANSCO and DISCOMs, so like that we are having, right students. So these are the question set you have to maintain. So if you are preparing questions from these, means definitely you are going to crack this examination, right students. Now first of all, operator J. What is operator J? Operator J means it rotates a vector, or we can say phasor, anti-clockwise by 90 degrees. So whenever you are having operator J, it rotates a phasor anti-clockwise by 90 degrees. See students, for example, whenever you are having a reference phasor like this, suppose if this is the reference phasor we are having, and this is the direction of the phasor. Say this phasor is having a magnitude of 1 and its angle is 0, that is why we are calling this as the reference phasor. Reference. Now any angle in the phasor diagram should be given with respect to this one only. So wherever you can draw, so you can draw here, you can draw here, you can draw here, the angle should be calculated from the reference phasor only. Now what is operator J? It rotates a phasor anti-clockwise by 90 degrees. Therefore, so we are saying that it is rotating anti-clockwise by 90 degrees from here. So that this is the next position of the phasor. This will be J into 1, which is nothing but J, right. So what is the angle shift from here to here? This will be 90 degree shift. right. So, this is j, which is nothing but what is the angle shift 90, so that you can write 1 at an angle of 90. What is the meaning of j? 1, magnitude is 1 only, no change in the magnitude, only angle will be changing 1 at an angle of 90. What is the mathematical value of j? Under root of minus 1. Under root of minus 1 is the mathematical value of operator j. Now, whenever you are multiplying this j with one more j, it will be rotated anti-clockwise by one more 90 here, like this. So, this will be j square. This is j square. What is j square? So, mathematical value will be minus 1. What is the angle shift from here to here? One more 90. What is the total angle shift, students? From the reference only you have to give the angle, right? Wherever the phasor you are drawing, you have to give the angle from the reference only. So, 90 plus 90, it will be 180, but magnitude is 1 only, the angle will be 180 degrees. So, see students, minus 1 means it is magnitude is 1, angle will be 180. Don't write minus 1 is the magnitude, magnitude is 1 and angle will be 180 degrees. And if you are shifting this one by one more 90 in the anti-clockwise direction from here to here, like this. This is the next position. The angle shift from here to here, it will be one more 90. This will be j cube. What is j cube? J square into j. It will be minus j. So, what is the total angle shift? 1 at an angle of from the reference. From the reference, it will be 90 plus 90 plus 90. It will be 270 degrees. That is j cube. J cube. Right. And whenever you are having one more shift by 90 degrees from here to here, that will be 1 at an angle of 360 degrees. So, that 1 at an angle of 0 is nothing but 1 at an angle of 360. So, we can say that the angle rotation in anti-clockwise direction is always positive. So, plus 90, again 90, again 90, again 90. So, the angles whenever you are moving in the anti-clockwise direction, they are always positive. So, that in anti-clockwise direction, angles are positive. Angles are positive. So, conversely, we can say that in clockwise direction, angles are negative. Angles are negative. Therefore, whenever you are moving in the clockwise direction from here to here, the angle will be minus 90. Whenever you are moving from here to here, the angle will be minus 90, and from here to here, the angle is minus 90. From here to here, the angle will be minus 90. So, all are minus 90s now. Now, first of all, from here to here minus 90. So, that this vector is having an angle of minus 90 in the clockwise direction and it is having 270 in the clockwise direction. Therefore, this can be written as 1 at an angle of minus 90. Therefore, plus j is 1 at an angle of plus 90 minus j 1 at an angle of minus 90. And minus 90 plus minus 90, it will be minus 180. So, that this vector in this direction it is having plus 180, in this direction it is having minus 180, it will be plus or minus 180. The meaning of minus 1 is plus 180 or minus 180. Magnitude is 1, angle will be plus 180 or minus 180, both are same only. And from here it is minus 90, total will be minus 270, it will be magnitude is 1, angle will be minus 270, and here it will be magnitude is 1, it will be minus 360. Like that, we can explain the operator j, students, right. So, we will write the values here. See here, j 1 at an angle of 90, j square 1 at an angle of plus or minus 180, you can write, it will be minus 1, which is nothing but 1 at an angle of plus or minus 180, j cube, which is nothing but minus j power 4, which is nothing but 1 at an angle of 0, that is 1 at an angle of 360. So, what is j power 4? This will be j power 4, 1 at an angle of 360 or 1 at an angle of 0. Now, what is 1 by j? 1 by j is nothing but j inverse. J inverse. What is j inverse, students? 1 at an angle of 90 whole inverse. or otherwise just see here J inverse means what? 1 by 1 at an angle of 90. In polar division 1 by 1 is 1 only. What is 1 at an angle of 90 in the denominator? Whenever it is goes to the numerator, its angle will become minus 90. So it is minus J. Therefore, J inverse is nothing but minus J. And what about J conjugate? J conjugate is nothing but 1 at an angle of 90 whole conjugate. 1 at an angle of 90 whole conjugate. Because of conjugate, it will become 1 at an angle of minus 90. So it is also minus J. So J conjugate is also minus J. J inverse is also minus J, right? So both are same only. J conjugate and J inverse both are same. Both are having the same values. Like that we can explain the operator J. Right. Now I will see the next part here. What is the importance of power factor? So what is the importance of power factor cos phi? So actually active power P is equivalent to VRMS into IRMS into cos phi. Actually it is VI cos phi. VRMS into IRMS into cos phi, that is VI cos phi. So here cos phi is called as power factor. Power factor. So you can see what are the advantages of high power factor. What are the advantages of high power factor? So you can write here advantages of high power factor. Of high power factor. We can see, students, whenever power factor of the system is increased, we can expect that there is some less current flow through the line, right? So current supplied by the source will be reduced. Current supplied by the source will be reduced. That is the first advantage. Whenever current supplied is reduced, the conductor, whatever we are using, that conductor cross sectional area we can reduce. So that cost of conductor will be reduced, right? So because of this one, cost of conductor will be reduced. Conductor will be reduced, right? And one more point you can take. So not only the current, whenever current is reduced, because of current, the power losses, I square R losses also are going to be reduced, right? Power loss in the line, power loss in the line will be reduced, right? And reactive power supplied, by the source will be reduced. Reactive power supplied is also reduced. Not only that one, whenever power loss are reduced, reactive power supplied is also reduced, the size of generator is also reduced. So we can say that the size of generator, will be reduced, right? So that cost of generation is also reduced. The cost of generation will be reduced. So because of the consumer is maintaining high power factor, we are getting the advantage, right? Whenever the consumer maintains high power factor or whenever load is maintaining high power factor, the generator side we are getting better advantage. So cost of conductor we are reducing, and power loss we are having less, and reactive power supplied by the generator, the burden on the generator will be reducing. That's why cost of generation is also reducing. That's why the electricity bill, means the tariff also we have to reduce for those consumers. So particularly we are saying the consumers which are operating at low power factor, whenever they are operating at high power factor, then only we are going to get the advantage. Suppose if already consumer is maintaining at high power factor, if that is improved, there is no advantage for us. Suppose, for example, if you are having a domestic consumer, the domestic consumer power factor is nearly 0.95, nearly 0.9 to 0.95, very high power factor. So that no need to improve the power factor of the domestic consumer. Household purpose, so whenever we are improving the power factor of a domestic consumer, there is no use at all. But the industrial consumer, he is having a lot of induction machines where the induction machine power factor will be very less, nearly 0.6, right. So whenever he is improving the power factor from 0.6 to 0.9, then we are going to get the advantage. That's why the tariff calculation for industrial consumer only we have to reduce, not for the domestic consumer. Why? Because domestic consumer already paying cost is less compared to that of industrial consumer, and he is having very good power factor. So that power factor correction is not the concept of domestic consumer, power factor correction is the concept of industrial consumer only, right. So we can say here the tariff for industrial consumer will be reduced, So you can say the tariff for industrial consumer, right, I am saying about only industrial consumer, it is some fixed charges we are having plus charges based on active power consumption, and charges based on reactive power consumption also we have to consider, reactive power consumption. So the reactive power consumed by the domestic consumer is very less, so that we no need to consider that one. So for domestic consumer we will take only first two parts, so there is no third part. For industrial consumer only we are having the third part. The industrial consumer which is having less reactive power consumption, he is having less tariff, right students. That is the advantage of maintaining high power factor in the system, right. So now we will see about the conductors. First of all we will see the three-phase system. First of all, why we are going for three-phase system rather than that of the single-phase system? Three-phase system is highly efficient. Why? Because number of conductors will be reduced, so the transmission efficiency will be improved. So high efficient and high loading capability compared to that of single-phase system. The three-phase system is having high loading capability and more economical compared to that of three separate single-phase systems. If you are using a single three-phase system, it is more economical, and balanced operation is also possible. In three-phase system, balanced operation is possible, right students. So these are the advantages of the three-phase system compared to that of the single-phase systems, right. What are the types of connections we are having here? There are two types of connections. One will be star connection and the other will be the delta connection. So whenever you are having three windings like this, these are the three windings. So suppose this is A1, A2, this is B1, B2, sorry, this will be B1, B2, this will be C1, C2, right. So when you are joining all the same points here, A2, B2 and C2, that will become the neutral point, that will become the star connection, Suppose when you are having three windings like this, this is A1, A2, B1, B2, C1, C2. Now we are connecting the different points. A2 we are connecting to B1, B2 we are connecting it to C1, C2 we are connecting it to A1. That is called as the delta connection. Alright students, these are the two types of connections we are having in the power system, right. What are the types of sequences? So we are having two sequences. One is positive phase sequence and the other one is the negative phase sequence system. Positive phase sequence. So in positive phase sequence, see, if this is rotating in the anti-clockwise direction, this vector is also rotating in the anti-clockwise direction, this vector is also rotating in the anti-clockwise direction. The person is standing here and he is looking like this. See, this person will see A phase first of all, later on B will meet him, later on C will meet him. So that what is the phase sequence of this one? A, B, C is the phase sequence. Similarly, here also A is rotating like this, C is rotating like this, B is also rotating like this. The person is standing here and he is looking like this. So that first of all A meets him and then C meets him and then B meets him. That is why phase sequence will be ACB. ACB. Right. Now see the question here. What is the phase sequence of this system? The phase sequence of a three-phase system shown in figure is, so they have given RYB, BYR, BRY and YBR. These are the questions given. Right. Any answer here? Any answer? I am waiting for the responses, students. Any answer here? Right. So, we will see here, it is one of the easiest question we can say. Whenever the person is standing here, R phase is rotating like this is B phase rotating like this, Y phase is also rotating like this. The first vector which is meeting him is R and then B and then Y. So that phase sequence should be RBY, but it is given RYB, so that it is wrong. It should be RBY. Suppose if the person is standing here and he is looking like this, first vector which is meeting him is B and then Y and then R and then R. It should be BYR, BYR. It is not BRY. Suppose, sir, if the person is standing here and he is looking like this, first vector which is meeting him is Y and then R and then B. It should be YRB, but it is given YBR. So, only correct answer possible is BYR. So, otherwise, in this way also you can remember RBY, that is the first cycle, for the first cycle. For the second cycle again we are going to get RBY only. For the third cycle again we are going to get RBY only. Like that, for every cycle same phase sequence it is going to repeat. First of all, I will start with R. What is the phase sequence? RBY. Suppose I am starting with B, it will become BYR. Whenever I am starting with Y, it will be YRB. That is why it is RBY, BYR or YRB. All are same only. All are same, right? That depends upon the starting point. If R is the reference point, RBY. If B is the reference, BYR. And if Y is the reference, YRB. Like that you can give the answer. Very simple question only. Right, very good, very good. Right, students. Now we'll see. What are the characteristics of the transmission lines? So we need the best transmission lines to transfer the electrical energy. So which type of characteristics we need? So this is also one of the most important topic we need to remember. So the conductor should have high conductivity. The conductor should have high conductivity. High conductivity means we can say it is having low resistivity. It is having low resistivity, right? Means it is having low resistance. Low resistance means it is having low power loss. Low power loss means it is having high power transfer capability. High power transfer capability. Means it is having high efficiency, high percentage efficiency. So that all are same points only, one point only have discussed. What is that? High conductivity, if you are saying, means you are indirectly saying that it is having low resistivity, low resistance, low power loss, high power transfer capability and high efficiency, right? And one more point you can take, low voltage drop. Low voltage drop means we can say low resistance and reactance both. But already have given resistance there, that's why I will write low reactance. Low reactance. And because of this one, low percentage voltage regulation. Low percentage voltage regulation. These are the two things to identify the performance of the transmission line we are going to calculate, right? So these are called as performance indices. Efficiency and regulation are the performance indices of the transmission line, right? First one is efficiency, second one is the regulation. So we need high efficiency and low voltage regulation. And high mechanical strength, it should have high tensile strength. High tensile strength. So when tensile strength is very high, sag will be less, low or less sag. Less sag we are going to have, right? And high thermal conductivity. So temperature it has to transfer, we can say high heat transfer. High heat transfer. High heat transfer means it cannot melt easily, it can withstand the temperature so easily. Means it cannot melt easily means it is having high melting point. High melting point. Or indirectly we can say high temperature withstanding capability. High temperature withstanding capability. Next one, low temperature coefficient alpha. So R2 is equivalent to R1 into 1 plus alpha into T2 minus T1. This is the variation of resistance with respect to temperature. Suppose if the temperature variation is very high, suppose in some of the states in India, initial temperature, suppose we will compare summer, winter and summer. In winter we are having 3 degrees, in summer we are having 47 degrees. Take a city like Delhi. So in winter we are getting nearly 2 degrees to 3 degrees, in summer we are getting nearly 47 degrees. There is very high change in the temperature. At that case resistance variation is also very high. That is why we need every seasonal calculations. Right? For every season we need to give the calculations. It is not that much easy to do load flow analysis on that much system. Got it, right? That is why whenever you are selecting the conductors, so the conductors should have very less resistance variation with respect to temperature. Right? So that is why we are selecting a conductor which is having low temperature coefficient. This is called as the temperature coefficient alpha. Suppose if this is approximately 0.0001, then it is 47 minus 3, it will be 44 into 0.0001, approximately 0 only. So that whenever this is 0, R2 is equivalent to R1. Like that we are selecting the conductors, right? That type of conductors only we prefer. And less weight, you should have high flexibility. High flexibility. So weight also increase the sag in the conductor. Whenever weight is less, they are very flexible to place on the transmission tower, right? And there is no chemical reaction, means there is no corrosion, right? And it should be available in the universe, right? And finally, it has to give all its best under low cost. These are the properties we need for the transmission lines. We can say properties of conductors, right students? Now, what type of conductors we are having? These are the conductors. So, this is the decreasing order of conductivity, like this. So, this is decreasing order of conductivity, right. So, first the best conductor, that is one of the previous question, right. Silver is the best conductor, and then copper, and then gold, and then aluminum, right. They are the first best. Later on we are having steel, iron, lead, stainless steel also, right students. So, finally we will select copper and aluminum, right. So, copper you have selected for very less distance, very small distance. For example, you can say house wiring. So, for house wiring we have to use copper conductors, not the aluminum conductors, right. For machine construction, for a fan construction or motor construction, or it may be any small transformer construction, so we need the copper conductors, right. And aluminum conductors for long distance, right, for long distance power transmission, we are preferring the aluminum conductors. So, aluminum conductors are having a less cost compared to that of copper, and aluminum conductors are having less density, means less weight per volume compared to that of copper, and also corona power loss in case of aluminum conductor also very less. So, we can say in case of this aluminum conductor, it is having low cost than copper only, right, compared to copper, less weight and less corona. They are the advantages of the aluminum conductor than that of the copper conductor. So, most of the students will think that sir, copper is best, right, why are you going for aluminum means. So, most of the students will think about the cost only, not only the cost is the reason, right. So, weight is also reason, and major reason is the corona phenomena, right students. Right. What are the classification of conductors? Solid conductors we are having, and homogeneous stranded conductors, ACSR conductors, and hollow conductors and bundle conductors. Homogeneous stranded conductors, these are also called as all aluminum conductors, AAC. ACSR conductors are also called as composite stranded conductors, right. We will see here. First of all, we are having a solid conductor. So, solid conductor, surface is very smooth, that is why corona phenomena is very less. That is why with respect to corona we can use solid conductors, but the problem with the solid conductor is it is having very high value of the skin effect, right. And the applications we can use in the cables. That is about the solid conductors, right. And we need to study about the skin effect also. So, what is the skin effect? Skin effect means, so whenever an AC supply is given to the solid conductor, the current concentrate majorly on the surface and it is not concentrating at the center. So, that phenomenon we are calling it as the skin effect. Got it right students? To avoid the skin effect in solid conductors, we are going for the stranding, right. So, we are going for homogeneous stranded conductors. Next one. So, the homogeneous stranded conductors, so like this we are going for the strandings. These are called as strands, small strands, right. Advantage is it is having less skin effect, and bending and twisting of this type of conductors will be very easy. That is why transportation is also very easy, right. That is why easy to transport. And the disadvantage of this conductors, see here the surface is smooth, but here the surface is not smooth, rough surface we are having. The rough surface will increase the corona loss. Surface is not smooth, that is why corona loss will be more. And they are having very less tensile strength. When tensile strength is less, high sag will be there. High sag will be there. So, that high sag is the problem of the homogeneous stranded conductors. These are also called as all aluminum conductors. AAC, all aluminum conductors we are having. Right, students? Right. What are the applications we can use in the service main? So, in the service main which is coming to the domestic consumer for your house, right, from the distributor wire to the energy meter, in between that one we are having a all aluminum conductors only, right. Next one, to increase the tensile strength of these homogeneous stranded conductors, AAC conductors, we went for all aluminum alloy conductors, all aluminum alloy. Conductors, right, students? These are the all aluminum alloy conductors. They are having somewhat less skin effect, and high tensile strength, and all are made up of aluminum only. That is why it is all aluminum. And alloy we are going to use is magnesium silicon alloy, and they are used in the distribution systems, right. And coming to the next one, the best one, aluminum conductor steel reinforced, aluminum conductor steel reinforced. Aluminum conductor steel reinforced, that is ACSR conductors. In case of the ACSR conductors, they are having less skin effect, less sag and high tensile strength, right. So, they are having less skin effect and less sag and high tensile strength also compared to that of the AAC conductors, right. And they are having non-uniform surface, that is why they are having more corona loss. And where we can use means everywhere, HVAC and HVDC, transmission and distribution, everywhere we can use the ACSR conductors. And coming to the next one, the hollow conductors. So, particularly students, hollow conductors and bundled conductors we are using to reduce corona power loss, right. To reduce corona power loss, we are having hollow conductors and bundled conductors. If the question comes to you, right, which of the following conductor is preferred to reduce corona? If bundle is the in the option, prefer bundle, right. If bundle is not there, then you can go for hollow. Best one to reduce corona power loss is bundle only, right. So, hollow conductors are having very less corona power loss, that is why to reduce corona we are going to use. The disadvantage of this one, they are having very less current density. Because of this less current density, we never prefer the hollow conductors for power transmission, right. So, with less amount of current, you cannot transfer total load. Suppose if the load is asking 100 amperes, we need to supply 100 amperes, right, through the transmission line. So, but this transmission line is having very less current density. To supply that 100 amperes through the hollow conductor is very difficult. That is why we do not prefer hollow conductors in power transmission, but where we can use means at the bus bar location we can use the hollow conductors, right, students. So, I am searching for students, are there any doubts, right. Next one, bundled conductors. So, these are the bundled conductors. So, advantages, less corona power loss, yes, but the disadvantage is high cost compared to that of the normal standard conductors or solid conductors. These conductors are having somewhat high cost. So, this is called as metal spacer, metal spacer. So, which increase the overall geometric mean radius GMR of the overall conductors. So, bundled conductors will increase the GMR value, right, and they are used in the HVAC transmission part. These are the applications. So, they are the various types of conductors we are having, right students. So, classification of conductors and what are the properties of transmission lines, what type of materials we can use for the transmission also we have seen. Now, see classification of transmission lines. So, we are having short transmission lines. The short transmission lines we are having for line length less than 80 kilometers and voltages more than less than that of 20 kilovolts. 20 kilovolts. And because of this one, in case of short transmission line, effect of capacitance is neglected, right? Capacitance effect is neglected. Capacitance effect is neglected. Right. And in case of medium transmission lines, so you can say 80 kilometers to 160 kilometers length we can prefer, and 20 kilovolts to 100 kilovolts we can prefer in the medium. Right. Here capacitance is lumped. Capacitance is lumped. Lumped parameter means lumped parameter means we are assuming that it is connected at one location only. It is connected at one location only. And in long transmission line, the line lengths are more than that of 160 kilometers and voltage magnitudes are more than that of 100 kilovolts. So, here capacitance is a distributed parameter. Capacitance is a distributed parameter. So, in case of short transmission line, there is no effect of capacitance, so that there is no charging current existed. Whenever there is no charging current, there is no concept like Ferrand effect in the short transmission lines. So, students, in case of short transmission line, we can say that no capacitance, so that no charging current, and no Ferranti effect. Means the receiving end voltage, whenever it is more than that of sending end voltage under no load condition, that phenomena we are calling it as the Ferrand effect. That concept you cannot get in case of the short transmission lines. Means whenever you are calculating percentage voltage regulation, it is the no load voltage minus the full load voltage divided by the full load voltage into 100. That is the formula we can take, V no load minus V full load divided by V full load into 100. So, full load voltage is somewhat less compared to that of the no load voltage. So, whenever full load voltage is less than that of the no load voltage, that is called as the positive voltage regulation. Sometimes full load voltage and no load voltage both are same. At that time we are having zero voltage regulation. Whenever we are having full load voltage is more than that of the no load voltage, that is called as the negative voltage regulation. Right. So, that in case of short transmission line, we can get positive voltage regulation, we can get zero voltage regulation, but we cannot get the negative voltage regulation, right. So, you can say that only positive voltage regulation and zero voltage regulation are possible. Negative voltage regulation we never get in case of the short transmission line. So, negative voltage regulation definitely we are getting because of the effect of the capacitance, right. Coming to the medium transmission lines. Students, here we are having effect of capacitance is there, charging current is existed, so that we are having Ferrand effect also, so that all the regulations are possible here. Positive voltage regulation possible, negative voltage regulation possible, zero voltage regulation is also possible in some cases. So here we are having load capacitor model or end condenser model, load capacitor model. Second one is source capacitor model. And middle capacitor model or nominal T model. Both sided capacitor model or nominal pi model. Nominal pi model. Right? These are the 4 different models we are having in the medium transmission lines. Right, students? So out of these, highest Ferrand effect will be there in the load capacitor model. Highest Ferrand effect. And source capacitor model, no Ferrand effect. No Ferrand effect means least, right? Highest, least, these are somewhat moderate, right? The best model is best model. So what is the best model of medium transmission lines means we can say nominal pi model or both sided capacitor model is the best model of the medium transmission line, we can say, right? Coming to the long transmission lines, in case of long transmission lines we are having the capacitance effect. Capacitance is distributed at every point, at every unit location, right? So there will be high charging current is there, so that all the definitely we are having positive voltage regulation possible and negative voltage regulation is also possible. Zero voltage regulation may not be possible. Why? Because so in between elements are lot, we are having very lot of elements connected in between load to the source. That is why zero voltage regulation is not possible in case of the long transmission line. So majorly positive voltage regulation and negative voltage regulation possible. How can I get zero voltage regulation? Means by using compensation we can get the zero voltage regulation in case of the long transmission line. Capacitive compensation or inductive compensation, based on the situation, by doing proper compensation we can get the zero voltage regulation in case of the long transmission line, students. Right, students? Right. See, in case of the long transmission lines, if this is the source, so here we are having some elements, right, like resistance, inductance, shunt conductance and shunt capacitance, like that we are having. Like that elements are there throughout the length. So here also resistance, inductance and shunt conductance and shunt capacitance, like this we are having. Here we are having the load. This is the load we are having. See, whenever load is disconnected, all the elements are existed there. That is why zero voltage regulation is not possible, right? Zero voltage regulation is not possible without compensation. So whenever we are doing some compensation, so then only we can get the zero voltage regulation. Got it right, students? That is about the introduction to the long transmission lines, right? Now we will see some questions here. In India, electrical power is transmitted by, any answer here? In India, electrical power is transmitted by. Any answer? Any answer? Shyam, Balaji, very good. 3 phase 3 wire, very good, very good. Just see, for this question I will give you some more clarity here. The voltage levels we are having in India are voltage levels we are having are 11 kilovolts, 33 kilovolts, 66 kilovolts, 110 kilovolts and 132 kilovolts. So, all these are called as HV levels, high voltage levels, and 220 kilovolts, this is called as EHV, extra high voltage level, right, and 400 kilovolts, modern EHV, MEHV level, and 765 kilovolts, this is called as ultra high voltage level, UHV level, ultra high voltage level, right. So it may be 11 kilovolts to 765 kilovolts. So, we can have category like this: HV levels, EHV, MEHV and EHV. So, all these are the transmission voltage, 3 phase 3 wires only we are going to use, 3 phase 3 wires. It may be 11 kilovolts or 33 kilovolts or 66 kilovolts, whatever it may be, everywhere we are using 3 phase 3 wires only, right. Suppose if you see distribution levels, distribution voltage levels, the distribution voltage levels, suppose if you are starting from 66, right, for example, we can start at 132 also, no problem, 66 kilovolts, 33 kilovolts, 11 kilovolts, right, these are called as primary distribution, primary distribution. In primary distribution, we can use 3 phase 3 wire only, 3 phase 3 wire. And coming to the secondary distribution, we are having 400 volts or 440 volts, approximately we can say 440 volts, right. But we cannot get 440, we will get nearly 415 volts. Right. Just check in your labs, in your colleges, you will get nearly 415 volts only, right. It is secondary distribution, and 220 volts single phase, right. It is also secondary distribution. So, here these two are secondary distribution, So, out of these only 440 volts range, we can use 3 phase 4 wire, and 220 volts it is single phase 2 wire, So, like that we can give the classification, right students. Just see, so where you are using 3 phase 3 wires, 3 phase 4 wires, only 440 volts range only we can give the 4th wire. Got it right students? Very good, Balaji and Shyam, right. So, what is the correct answer here? 3 phase 3 wire AC system. What is the full form of ACSR? Full form of ACSR, all copper stranded reinforced, aluminum conductor steel reinforced, all copper steel reinforced, aluminum copper steel reinforced, aluminum conductor steel reinforced, aluminum conductor steel reinforced. Right, very good. ACSR stands for aluminum conductor steel reinforced, right. Power is transmitted over transmission lines on high voltage because whenever voltage is increased, current is reduced, efficiency is increased, conductor cost is reduced, both conductor cost is reduced and efficiency is increased. What is the answer? Very good, Shyam. Right. So we can say here P is equivalent to Vi cos phi P is equivalent to Vi cos phi, which is constant, power is constant. So whenever we are increasing the voltage level, current will be reducing. But whenever current is reducing, we are saying, but load is asking 100 amperes, we have to supply that 100 amperes. Current can reduce, definitely okay, but whatever the load is asking, that much amount of current you have to supply, now definitely. Got it right, students? That's why as we are supplying the same amount of current whatever the load is asking, but that amount of current we can supply through somewhat less cross sectional area conductor. Why? Because as we are maintaining high voltage level, current flow in the line can be reduced, means a small cross section conductor can supply more amount of current. That is the meaning of that one. Got it right? So that conductor cost reduce, conductor size and cost reduce. And as current is reduced, we can say power loss can be reduced. Power loss decreases, so that we can say percentage efficiency increases. Percentage efficiency can be increased. So that we can say, so both conductor cost is reduced and efficiency will be increased, we can say. That is the option we can give. Very good. Very good. Right? Means the same conductor which can operate at high efficiency. Right. For a 500 Hz frequency excitation, a 50 km short power line will be modeled as. For a 500 Hz frequency system, so a 50 km short power line can be modeled as. See, whenever frequency increases, charging current increases. Charging current increases. That's why, so we can take, even though line length is 50 kilometers, because of high charging current, we have to go for the long transmission line. We have to go for the long transmission line, students. Alright. Right. The concept of electricity short, medium and long line is primarily based on. The concept of electricity short, medium and long line is primarily based on what? Nominal voltage of the line, physical length of the line, wavelength of the line, or power transmitted over the line. It is not the nominal voltage, it is not the physical length, it should be the wavelength of the line. Based on the wavelength of the transmission line, we are going to classify the transmission lines. Right, students? Based on the wavelength of the transmission line. Right. In which of the following transmission lines is the capacitance effect is negligible? In which of the lines capacitance effect will be negligible? Both long transmission lines, short transmission lines, long transmission lines and medium transmission lines. Which question, Shyam? Which one? This one? Wavelength? Shyam, which one do you want to explain? Which question? This one? Say if this is first one, this is second one. Which one? 1 or 2? 1 or 2? Give me the number. Wavelength. See here, the wavelength of the transmission line, wavelength lambda is equivalent to velocity of travelling wave, wavelength is equivalent to velocity of traveling wave divided by supply frequency. Supply frequency, right? So, at constant frequency, we are calculating a wavelength of the transmission line. Suppose velocity of the traveling wave is 3 into 10 power 5 kilometers per second and supply frequency is 50 hertz. For this one, we are going to get this as 6000 kilometers. That is the wavelength of the transmission line. Means to get receiving end voltage is equivalent to sending end voltage. Listen carefully. To get receiving end voltage is exactly equivalent to sending end voltage. What is the length of the line you have to maintain? 6000 kilometers. Without any compensation to get the 0 voltage regulation. So, to get 0 voltage regulation means VR is equivalent to VS, sending end voltage and receiving end voltage both are same means regulation will be 0. Under that condition, so to get that condition we need to maintain a length of 6000 kilometers line, but practically it is not possible. That is why we are not following this one. Why? Because 6000 kilometer length of line, how can I place? So, total earth surface, earth radius is nearly 6000 kilometers. So, that I need to use a line of 6000 kilometers means earth radius approximately equal to that much length I have to place. That is why. So, initially we have started the classification with wavelength only, but it is not possible to use with wavelength, but still we have to maintain the frequency constant. By maintaining frequency constant, we can go for voltage levels, physical length of the transmission line. But what is the basic way? What is the question they are asking? The concept of electricity short medium line primarily done based on what means physical wavelength of the line. Wavelength, right? Initially. Got it right? Shyam, is it clear? Right. Right. In which of the following transmission lines is the capacitance negligible? In which of the following transmission lines is the capacitance negligible? Both long transmission lines and short transmission lines, long transmission lines. Very good Balaji and Shyam. It is short transmission lines, already explained. Right. In case of short transmission lines, there is no effect of the capacitance because of less charging current, you can see. Right, students. So, these are the questions, previous questions we are having from the transmission and distribution part. Right. So, remaining concepts we will discuss in the next class, that is the tomorrow's class. So, try to attend the class from 7 tomorrow. Right. So, here we are having 30% off for all SSC JE and RRB JE students. So, you can use the code SCS30, right, up to 8th and 9th April 2025 students. Right. So, students, that is all for today's session. If you are having any doubts, please clarify your doubts. If you are having any doubts, please clarify your doubts. Yes, those students who have joined in the classes, in the app we are uploading the notes also. Thus, right, those who are attending the classes, we are uploading the PDF notes also. Right. Okay, Shyam. Right. All right, students. Still, if you are having any doubts, please clarify doubts. And that's all for today's session. Thank you, everybody. Right.